Hi KCET 2026 aspirants, so welcome back to Sankalp series, and in today's class we are going to solve the KCET PYQs of the chapter Chemical Kinetics. Okay, so we are doing almost for last 10 years of PYQs. All important questions are there, so do practice with me. Put down the scores in the comment section, or if you find any question difficult you can also comment down, and I want all of you to put the score for yourself after the entire video is over. Okay, so the first question is from the rate law, which tells that the rate of a gaseous reaction in the in the expression KAB square, if the volume of the vessel is reduced to 1/2 of the volume, the reaction rate as the original rate is. Okay, so the rate expression is given like this: K into A into B square. Okay, if the volume of the vessel is reduced to 1/2, okay, so R dash I can write like this: A by 2 and B by 2. Okay, so that will give me K into A B square by 8. Okay, now what I want, if the volume of the vessel is reduced to 1/2 of the volume, the reaction rate as original rate, means R dash by R I have to do. So R dash by R, so that is K by 8, okay, into AB square, and I have R here, AB square. Okay, so if I solve this I will get 1 by 8. Okay, so I can say that now R dash is equal to R K into 1. Okay, here also K is there, right? So this K will also get cancelled. 1 by 8 times, right? So option number B is the correct answer here. Moving to the second question, for the reaction 2N2O5 gives 4NO2 plus O2. The initial concentration of N2O5 is 2 moles per liter, and after 300 minutes it is reduced to 1.4 moles per liter. The rate of production of NO2 is. So if I just want to write this reaction, so I can write minus 1 by 2 of dN2O5 by dt, okay, is equal to 1 by 4 of dNO2 by dt is equal to dO2 by dt. Okay, the initial concentration of N2O5 is 2 moles per liter, and after 300 minutes it is reduced to 1.4 moles per liter. So I can write that the rate of production of NO2. So I can write rate of production of NO2 can be written as 2 times of dN2O5 by dt. Okay, can be written as 2 times of dN2O5 by dt. So that is equal to 2 into, what is the change in concentration of N2O5 from 2 moles to 1.4, that means 0.6 mole, and the time change, this has happened in 300 minutes, right? So it is 1.2 by 300, or I can write it like 12 by 3000, right? So 3 4s are 3000s are for 4 into 10 to the power of minus 3. So option number C here. Okay, moving to the next question, for an elementary reaction 2A plus 3B gives 4C plus D. The rate of appearance of C at time t is this much, then the rate of disappearance of B at time t will be. So I have now minus 1 by 3 of dB by dt is equal to 1 by 4 of dC by dt. Okay, now the rate of disappearance of B at time t will be equal to dB by dt will be equal to 3 by 4 of dC by dt. Okay, so 3 by 4, and what is the change in dC by dt? The rate of appearance of C at time t is 2.8 into 10 to the power of minus 3. 2.8 into 10 to the power of minus 3. So now this becomes, if I solve it, 2.1 into 10 to the power of minus 3, or 3 by 4 into 2.8 into 10 to the power of minus 3, that is option number A here. Now moving to the third question, 1 liter of 2 molar CH3COOH is mixed with 1 liter of 3 molar C2H5OH to form an ester. So we have what? The reaction is between acetic acid and ethanol. So CH3COOH plus C2H5OH gives here CH3COO, okay, then I have C2H5, right? So what is the rate here? Rate is equal to K into concentration of CH3COOH into C2H5OH, okay, that is there. So now the rate of the reaction with respect to the initial rate. So now what happens, suppose I write initial rate is equal to, what is the concentration of CH3COH? 2 moles in 1 liter, right? So I can write 2 by 1, and for this one it is 3 by 1, okay. Now what happened with the initial, when each of the solution is diluted with an equal volume. So now if I have diluted it with an equal volume, so we have 2 divided by 2. So I have made both the volumes double here. Okay. So now if I want to divide R dash by R, okay. So if I just divide this one, I can write K into 1 into 1.5, okay, divided by K into 2 into 3. Okay, so that will give me 1.5 divided by 6, or I have this 15 by 60, okay, and that will give me 1 by 4 or 0.25. So the answer here will be option number A. Okay, moving to the fourth question, for the reaction 2SO2 plus O2 gives 2SO3, the rate of disappearance of O2 is given, the rate of appearance of SO3 is. So O2 and SO3 we have to link. So from differential equation I can write minus dO2 by dt is equal to 1 by 2 of dSO3 by dt. Okay, so now can I write this one as, the question is asked the rate of appearance of SO3. So that is equal to 2 times of dO2 by dt. Okay. So that will give me 2 times of O2, means 2 into 10 to the power of minus 4. So that will give me 4 into 10 to the power of minus 4. So that is option number B here. Okay. Moving to next question number 5. For the reaction half A gives 2B, the rate of disappearance of A is related to the rate of appearance of B by the expression. So what is the relation here? So I have here 2 times of minus, I have here minus 2 times of dA by dt is equal to 1 by 2 of dB by dt. Okay, so how can I write this one? This can be write minus dA by dt is equal to 1 by 4 of dB by dt. Okay, so that will give me minus dA by dt is equal to 1 by 4 of dB by dt, which is option number A. Now coming to question number 6, which of the following statement is incorrect? So molecularity is only applicable for elementary reactions. The rate law for any reaction cannot be determined experimentally. See, molecularity is only applicable for elementary reaction. This is a correct statement. The rate law for any reaction cannot be determined experimentally. No, the rate law is determined experimentally only. So this is completely incorrect statement. So option number B is the correct answer. Next, for a chemical reaction Ma gives Xb, the rate law is R is equal to K into A square. If the concentration of A is double, the rate will be. So we have this one, R is equal to K into A square. If concentration of A is doubled, so we have like this. Okay, so it will become R is equal to 4 into K into A square, right? So if I just divide this one, I will have, this is R dash by R is equal to 4. So the rate has increased by 4 times, or it is called quadrupled. Next we have question number 8. 3A gives 2B, the rate of the reaction, that is dB by dt, is equal to. So I have minus 1 by 3 dA by dt is equal to 1 by 2 of dB by dt. Okay, so now if I solve this, I'll get here 2 by 3 minus 2 by 3 dA by dt, which is option number B. Okay, very simple question. Next, 100 centimeter cube of 1 molar acetic acid was mixed with 100 centimeter cube of 2 molar ethanol to form an ester. The change in the initial rate if the solution is diluted with equal volume of water. So we have done this question previously, like the same question. So for example, you have we have this reaction, right? CH3COOH plus C2H5OH will give me one ester, right? So the rate here will be equal to K into concentration of CH3COOH into concentration of C2H5OH. Okay, now here I'll give K into CH3COOH is 1 molar by 100 centimeter cube, and here I have 2 molar by 100 centimeter cube. Okay, now rate dash, R dash will be when the concentration has changed. Okay, so in both the cases the volume has doubled, so it is 1 by 200 and I have 2 by 200. Okay, so R dash by R. So here what I will get, it will be K into 1 by 200 divided by 2 by 200. Okay, and here I have K into 1 by 100 and 2 by 100. Okay, so now if I solve this, you will get 1 by 4 or 0.25 times, which is option number B here. Next, in which of the following reaction the rate constant has the unit of mole liter inverse second inverse? So mole liter inverse second inverse is the unit of 0th order reaction, right? So that's why I have told you to remember the examples for 0th order, so that such type of questions you can know which example is a 0th order reaction. Acid catalyzed reaction, no. This is also not a 0th order reaction. Surface catalyst reactions are 0th order reaction. So decomposition of HI is a 0th order reaction and its rate constant will be mole liter inverse second inverse. 11th question, the rate of the reaction is given by the equation this one. If the concentration is expressed in mole liter inverse, the unit of K is. So you can see here that this is also 1, this is also 1, so the order of the reaction is 2. Okay, so what will be the unit of rate constant? You have moles to the power of 1 minus n, liter to the power of n minus 1, second inverse. So I have moles 1 minus 2 minus 1, liter is 1, second inverse. So I have here mole inverse liter second inverse, that is option number A. Moving to question number 12, for a reaction A plus 2B gives product, when the concentration of B alone is increased, half-life remains the same. Okay, so if you increase the concentration of B, the T half remains same. Okay, so that means what? I can say that when the concentration of B is the half-life remains same means with respect to B, or for B the half-life is independent of the concentration, right? So what I can conclude here, for B the T half is independent of concentration. Okay, so what does that mean? That means which half order is independent of concentration? The first order half-life or half-life formula is independent of the concentration. That means we can say that B is having an order of 1. Okay. Next, if the concentration of A alone is double, the rate remains the same. So now for A, if the concentration of A is increased, the rate is constant. Okay, if the concentration of A is increased, the rate remains constant. So that means what I can say, that the concentration of A, or for A, rate is not affected by concentration. Okay, for A the rate is not affected by concentration. So that means I can say that with which order reaction is that? That is a 0th order reaction, means when you change the concentration the rate is not affected. So that is with respect to A. With respect to A it is a 0th order reaction. With respect to B it is a first order reaction. Okay, so now can I write the equation here? Rate is equal to K into A to the power of 0 and B to the power of 1, right? So what I will get here, rate is equal to K into concentration of B. Okay, so this is a first order reaction. So if it is a first order reaction, then what will be the unit for first order reaction? Second inverse, that is option number A. Next, the value of the rate constant for pseudo first order reaction depends only on the temperature, depends on the concentration of the reactants present in small amount, depends on the concentration of reactants present in excess amount, is independent of the concentration of the reactant. See, rate constant always depends on the temperature. Okay, so that is why it depends only on temperature. Option number A is the correct answer. If the question would have asked the rate depends on what, then the rate depends on the concentration of the reactant present in small amount. Okay, but here it is asking for rate constant, so that is why option number A. Next, we'll go to integrated rate law equations. The rate constants for a first order reaction is K, time T required for the completion of 99% of the reaction is given by. So we have here K equal to 2.303 by T log of 100. Now see, 99% is completed, so 1% is remaining, so that is 1. Okay, so I have now the question is asked the time required. So it is 2.303 by K log of 10 to the power of 2 or 2 log 10. So it is 4.606 by K. Okay, so that is option number A here. Next, question number 15. The time required for 60% completion of first order reaction is 50 minutes. The time required for 93.6 completion of this reaction will be. Okay, so time required for 60%. Okay, that means 60% of the reaction is completed. So I can write, so okay, 1 second. Okay, so I can write here for 60% completion. So K was equal to how much? 2.303. Okay, for 60% completion, how much time is required? 50 minutes. Log of 100 by 60% is completed, so I have left with 40, right? So I can solve this. 5 by 2 I'll get. You have to keep it like this. Then I want, the question is asking for 93.6% completion. So for 93.6% completion, K equal to 2.303 by T log of 100 by, see, 93.6% is completed, that means left is 6.4. Okay, so now if I just solve this, time required for this one. Okay, so this one will give me, I can just substitute the K value here. So that is 2.303. What is the K value? 2.303 log of 5 by 2 is, I can write it as 2.5. Then I have 50. Okay, and I have log of 1000 by 64. So now if I solve this value, you can solve this one easily. You can just cancel it. It is, it can be written as 10 to the power of 3. It can be written as 2 to the power of 6. You know, log 10 is 1, log 2 is 0.301. So you can just solve this, and if you solve this, you will get 150 minutes. Okay. Next, next we'll move to question number 16. This is important question. Okay, for gaseous reactions, A gives you P plus Q plus R, follows first order kinetics with a half-life of 69.3 seconds at 500 degrees Celsius. So what is T half? 69.3 seconds. So what I can write it for K value? K value is 0.693 by T half. Okay, so that is equal to 693 into 10 to the power of minus 3 divided by 693 into 10 to the power of minus 1. So if I cancel this, I'll get minus 2. Okay, now starting from the gas A enclosed in a container at 500 degrees Celsius and at pressure of 0.4 atm, the total pressure of the system after 230 seconds will be time after. So we have to calculate the total pressure after 230 seconds. So you have A here, which gives P plus Q plus R. So here I have 0.4 pressure. Now 0.4 minus X, X, X and X. What is the total pressure here? Total pressure here is 0.4 plus 2X. Okay, that is the total pressure. So now what I want to calculate, if I just use the first law of integrated equation, K equal to 2.303 by T log of P naught by P. Right, this is the equation. So what is the K value that I have got? 10 to the power of minus 2. 2.303. Time they have asked me is, what is the time? 230 seconds. So I'll just write it in this way so that it is more clear. So let us assume that it is 2.30 and let me write it in the form of 230 into 10 to the power of minus 2. So that will give me 2.303 and log of, what is P naught value? 0.4 and pressure after 230 seconds. This is after 230 seconds is 0.4 minus X. Okay, so now if I just cancel this one, everything, I'll get here 1 is equal to, this one I can cancel, this one I can cancel, log of 0.4 by 0.4 minus X. So if I take anti-log on both the sides, 10 is equal to 0.4 minus 0.4 minus X. Now if I multiply this on both the sides, I'll get 4 minus 10X is equal to 0.4. Okay, now if I just solve this, I'll get 3.6 is equal to 10x or x is equal to 0.36. So 0.36 is the x value. Okay, but our question is to find the total pressure. So what is the total pressure? 0.4 plus 2x. So I can just include this one here. 0.4 plus 2 into 0.36. That will give me 7 to 1.12 atm. Okay, so the correct answer here will be option number D. Now moving to question number 17. For the reaction PCl5 gives PCl3 plus Cl2, the rate and the rate constants are respectively given. The molar concentration of PCl5 at that instant is. So if I have this equation, I can write for this reaction rate is equal to K into PCl5. Concentration is PCl5. Now the rate is how much? 1.02 into 10 to the power of minus 4. Okay, and the rate constant is 3.4 into 10 to the power of minus 5. That is PCl5. So now how much, if I just, what is the concentration of PCl5 here? That is equal to 1.02 into 10 to the power of minus 4 divided by 3.4 into 10 to the power of minus 5. Okay, so now if you see, you can just see this, if I multiply 3, I'll just calculate this one, this goes up, so I'll get 10.2 divided by 3.4. okay, so that will bring me this one, so this is 3 times, right? So what is the answer here? 3 moles per liter, option number B. Next, question number 18. First order reaction is half completed in 45 minutes. How long does it take for 99.9% completion of the reaction? So here you know one relation, T 99.9% is equal to 10 times of T 50%. Okay, so it is 10 times of 45 minutes or yeah. Okay, so that gives me 450 minutes. Okay, now T 99.9%. Okay, now 450 minutes, if I convert it into hour, that will become 7.5 hours. That is option number D here. Now moving to 19th question, the half-life period for a first order reaction is 60 minutes. What percentage will be left over after 240 minutes? Okay, so you have the half-life period of a first order reaction is 60 minutes. What percentage will be left after 240 minutes? So suppose I started from 100. Okay, so the half-life is 60 minutes. So after 60 minutes it becomes 50%. Then again after 60 minutes it becomes 25%. Then after 60 minutes it will become 12.5%. okay, then again after 60 minutes it becomes 6.25%. okay, so now it will have 6.25% left. That is option number A here. Now question number 20 here, for nth order reaction the half-life is directly proportional to. So if you know half-life, okay, is proportional to 1 by a to the power of n minus 1. Okay, now if this one goes, yeah, so 1 by a to the power of n minus 1, that is option number C here. Now regarding this, a question is there, for a half-life of a reaction is found to be inversely proportional to 1/5 power, is inversely proportional to the 5th power of its initial concentration, means T half is proportional to 5th power of its concentration. Then the order of the reaction is a to the power of n minus 1 is this much, right? So n minus 1 is equal to 5, so n is equal to 6, that is option number B here. Now question number 22, the plot of T half versus R naught for a reaction is a straight line parallel to x axis. The unit of rate constant for the reaction is, now see, the plot of T half versus R naught. T half versus R naught, okay, for a reaction is a straight line parallel to x-axis, is a straight line parallel to x-axis. The unit for the rate constant of the reaction is, so if you know that for a first order reaction, what happens, for a first order reaction the rate constant or the T half is I can say is independent of the initial concentration, right? T half is independent of the initial concentration. So for this one the unit will be second inverse because it is a first order reaction. Moving to 23rd question, in a first order reaction the concentration of the reactant is reduced to 12.5% in 1 hour. Then when was it half completed? So if I see 100%, it became 50%, then it must have become 25%, then it has become 12.5%, right? Now this all took how much minute? 60 minutes, right? So that means this one would have taken 20 minutes, 20 minutes, 20 minutes, right? So when was it half completed? It was half completed in 20 minutes, that is option number A here. Now moving to question number 24, half-life period of a first order reaction is 10 minutes, starting with initial concentration of 12 molar, the rate after 20 minutes is. Now see, okay, the question is asking for rate. So what is the formula for rate? Rate is equal to K into concentration, right? Okay, so now we need the concentration after 20 minutes. What is the concentration after 20 minutes? So we started with 12 molar, okay. What is its half-life? Its half-life is 10 minutes. So after 10 minutes it would have become 6 molar. Then another after 10 minutes it would have become 3 molar, right? So after this 20 minutes, what is the concentration? 3 molar, okay. Now what is the K value? K value I can calculate 0.693 by T half, which is your 10 minutes, right? So now can I just calculate this one? So I will get 0.693 by 10 into 3. So I can just multiply, 3 3s are 9, 3 9s are 27, 3 6 are 18, 19, 20, and then we have 0.2079. Okay, we just have to multiply, just a minute. Okay, you just don't have to multiply. So this one will become 0.0693 into 3. 0.0693 into 3, that is option number D here. Now moving to question number 25 or the next question. Half-life of a first order reaction is 20 seconds and the initial concentration of the reactant is 0.2 molar. The concentration of the reactant left after 80 seconds is, okay. So you have the half-life of a first order reaction is 20 seconds and the initial concentration is 0.2, okay. And after 20 seconds what would have happened? It would have become 0.1. Again after 20 it would have become 0.05, and again after 20 it would have become 0.025, right? So 20, 20, 20, okay, one more 20 I have to go. So 20, 20, 40, 20, 60, 20, 80. So it will become 0.0125. So that is 0.0125, option number 2 here, okay. Next, moving to question number 25, the rate constants K1, so Arrhenius equation we have come now. The rate constants K1 and K2 for two different reactions are 10 to the power of 16 into e to the power of minus t 2000 by T and 10 to the 15 into e to the power of minus 1000 by T. The temperature at which K1 is equal to K2 is, okay, very important question. So I have here K1 value is how much? E to the power of minus 2000 by T, okay, into 10 to the power of 16. And what is the value of K2? 10 to the power of 15 into e to the power of minus 1000 by T. Okay. Now the temperature at which K1 is equal to K2. K1 should be equal to K2. E to the power of minus 2000 divided by T into 10 to the power of 16 is equal to 10 to the power of 15 into e to the power of minus 1000 by T. Now if I just solve this, it will become 10, and if I have minus 1000 by T, e to the power of minus 2000 by T. Okay, so now if I solve this, it will become plus, so I have e to the power of 1000 by T, that is equal to 10. Okay, now what I can do, I can just convert it into ln this one. So I can write ln of 10 is equal to 1000 by T. Now if I want to convert it into log, I can write 2.303 log 10 is equal to 1000 by T. So that becomes T equal to 1000 by 2.303. Okay, so that is option number C here. Next, we'll come to question number 26. The rate constant for a reaction is given by PZE into e to the power of minus EA by RT under standard notation. In order to speed up the reaction, which of the following factors has to decrease? So we know that if activation energy decreases, the rate of the reaction increases. So it has to be option number B, that is the activation energy decreases. Next, we have when the temperature coefficient of a reaction is 2 and when the temperature is increased from 30 to 90, the rate of the reaction is increased by 30 to 90. Okay, so now suppose here it is 2. Okay, so 1, 2, 3, 4, 5, 6. So 2 to the power of 6. So 2 to the power of 6 is 2 into 2, you have to multiply for 6 times, right? So you can just do it. 2 to the 4 to the 8 to the 16, 32, 64 times, that is option number D. Next, question number 28. Which of the following is statement is in accordance, means it is true with respect to Arrhenius equation? The rate of the reaction increases with the increase in temperature. Yes, that is correct. The rate of reaction does not change with the increase in activation energy. It changes. Rate constant decreases exponentially with the increase in temperature. No, it increases. The rate of a reaction decrease with the decrease in activation energy. No, the rate of the reaction increases with the decrease in activation energy. So first statement is the correct statement. Next, moving to question number 29. The activation energy of a chemical reaction can be determined by evaluating the rate constants at two different temperatures, changing the the activation energy can be of a chemical reaction can be determined by, so evaluating the rate constants at two different temperatures, changing the concentration of the reactants, evaluating the concentration of the reactants temperatures at two different temperatures, okay, evaluating the rate constants at standard temperature. So if you know the equation, we have log K2 by K1 is equal to EA by 2.303 R 1 by T1 minus 1 by T2. So what I can say, by evaluating the rate constants at two different temperatures. So that is your option number A. Now moving to question number 30 here, which is a wrong statement. Okay, rate constant K equal to Arrhenius constant if activation energy is 0. So if I have this equation, see, if activation energy is 0, then what I will have here, right? And if e to the power of 0 is 1, that means k is equal to a. So this is a correct statement. E to the power of minus Ea by RT gives the fraction of reactant molecules that are activated. Yes, this is also correct. ln K versus 1 by T plot is also a correct straight line. That is also correct. Presence of catalyst will not alter the value of Ea. This is wrong. Presence of catalyst decreases the value of Ea. So this is a wrong statement. That is option number D. Next, we'll move to 31st question, a numerical question here. For the reaction A to B, Ea is 50 kilojoule per mole and delta H is minus 20 kilojoule per mole. When a catalyst is added, Ea decreases by 10 kilojoule per mole. What is the Ea for the backward reaction in presence of the catalyst? Okay, so we have a forward reaction A to B. Okay. We have a forward reaction A to B. Okay, when a catalyst is added, Ea is how much? This one, this value is 50 kilojoule. Okay, and delta H value is minus 20. Okay, and delta H value is minus 20, or you can just simply write 20 kilojoule per mole. Okay. Okay, next, when a catalyst is added, the Ea decreases by 10 kilojoule per mole. So when a catalyst is added, this Ea will decrease by how much? By 10 kilojoule per mole. It decreases. So what is this value? This is now 40. Okay, the question is asked the Ea for the backward reaction in presence of the catalyst. So if I have this catalyst in the backward reaction 40 plus 20, so the total energy for the backward reaction is 60. So that is option number A here. Okay, now moving to question number 32. Which of the following does not represent the Arrhenius equation? Does not represent the Arrhenius equation. Log K is equal to A into e to the power of minus Ea by RT. Log K is equal to log A minus Ea by 2.303 RT. That is there. K is equal to A ln. If you write this equation in terms of ln, we'll get this one. But this is a wrong statement because it is minus Ea by RT. So that is why option number D here. Now moving to question number 33. For a reaction, the value of rate constant at 300 Kelvin is this much. The value of A at infinite high temperature. Okay, so if you see, I have K is equal to A into e to the power of minus Ea by RT. Okay, at infinite high temperature means I can write T is equal to infinity. So anything to the power infinity is 0. So I'll get K into minus Ea by R into infinity. So that will give me K equal to A into 1 by infinity, something will give me yes, this one will give me 0. Okay, so that is equal to K equal to A. Okay, so K equal to A is 6 into 10 to the power of minus 5. So the value of A will be equal to 6 into 10 to the power of minus 5. Okay. 1 second. Yeah, I think this option is slightly change in the, yeah, so I'll check the option, but answer will be 6 into 10 to the power of minus 5. I think there's some error in this typing. Okay, so that is option number D most probably. I think there's a minus left here, but the answer will be this one. Okay, next we'll move to question number 30. Next question, this is a 2025 question. In the given, Ea for the reverse reaction will be activation energy for the reverse reaction. This is very simple to calculate. Total is 215, here is 90, right? So for reverse reaction, I need, this is the activation energy, 215 minus 90. Okay, so that will give me how much? So I have 125. Yes, 125 is the answer, option number B here. Now moving to the next question. Question is from the topic of catalyst. Again 2025 question. Catalysts are used to increase the rate of a chemical reaction because it decreases the activation energy of the reaction, brings about improper orientation, increases the potential energy barrier, increases the activation energy. It doesn't nothing of this. It decreases the activation energy, as a result of which the rate of the reaction increases. So option number 1. Now next, higher order reactions are rare due to, so we know that orientation, proper orientation is possible only for 3 molecules. So the shifting of equilibrium towards the reactions due to elastic collision, nothing like that. Loss of active species, no. Low probability of simultaneous collisions of all the reacting species, yes. For more than 3 particles, all the species should collide at the same time. The probability of this one is very less, so option number C here. Okay, so that's all students. We have discussed almost 35 questions, I guess. So just put down your scores, how much you are getting, which question. If you have any doubt, do put down in the comment section. I'll address all the doubts. Okay, so that's all in this video. Thank you for watching and all the very best.